Okay, I'm going to look at simplifying exponents. So right here is our question. Our base is the letter x. It stands for any variable. And then we have also letters standing in places of the powers of the exponents. We have values here, so we're going to take these values and replace these variables with them because it's telling us that a is equal to something, d is equal to something, so we'll replace those letters with the actual numeric values. And then the question is asking, it's very poorly written, after simplifying, what would the value of the exponent be? Okay, so the assumption is because the base is the same, we'll end up with a single value of the power or the exponent, and what will that power be? So first thing I'm going to do is I'm just going to kind of attach some things. So here's a is going to be -1, b is going to be also -1, c is going to be 9, d is going to be 6, and I think I can hold it. All right, I'll do purple for e. E is going to be -10. So I'm going to rewrite this. The right one? Yeah, it is. Okay, so we have a to the power of -1, okay? And then that is also the b value there, so that entire value is to the power of -1 again. And then in our denominator, we have x to the power of c was the value of 9. And I'll write it here. E, just because I have purple set up right now, is the power of 10, so I'm going to do that one first, and then I'm going to go back and do D was the power of 6. Okay, so if you quickly check, we've plugged in our exponents according to the information now. I have to go about simplifying all this. So there's quite a few exponent rules we have to go through. The first one we're probably going to want to deal with is dealing with a power of a power. So anytime you have this situation, I'll write the rule over here on the side. Let's say we had x to the a b. This is how they'll usually write a rule, which is exactly how it started. What that is you end up with the same base, and you just end up with whatever a is, so the value of a times the value of b. So in our very first one here, we have -1, -1. So if we were to simplify this, I'll shrink it a little. I'm not sure why that's happening. There we go. Shrink this a bit. The very first one here, we'll say that, right on the next line, x to the power of, I'm just going to write it, actually no I won't, -1 times -1, okay? So we're going to carry that out. I'll leave everything else the same, x power of 9, and then x to the power of 6, which is also going to be to the power of -10. Okay, so we're dealing with the very first part here. -1 times -1. -1 times -1 is actually just +1. So we have our first numerator, so we'll continue here. X to the power of 1 is our numerator. That's all nice and simplified. Let's go towards the bottom now. So we have x, and that is still to the power of 9. And then since we've just went over this rule, I'm gonna do it again here. You'll notice that this is a power of a power, so we're gonna multiply those two powers together. So we'll have x to the power of, let's see if I can fit it in, -10 times 6. Okay. Okay. So 6 times -10 is actually going to be -60. So I'm gonna shrink a little again. I guess I could have my equal signs on the side here. So we have x to the power of 1 over x. This is still to the power of 9. We haven't dealt with that one yet. And then this will be x to the power of -60, like we said. Great. Okay, let's continue. I still have room up here. This will be equal to. So we have the next rule we're going to talk about is the rule of when we have two values that have the same base, how we simplify their exponents. So if you have a situation where, I'll write it here, let's say we have x to the power of a times, well, I like it a little smaller, x to the power of b, you end up with, x to the power of a plus b. So you actually just add those two values together. Okay, so when we have a power of a power, so we multiply, but we have two exponents multiplied by each other, we actually just add the values of the exponent. So I'm going to leave the numerator, x to the power of 1, that's still the same. But we're going to have just base x, and now we're going to have 9 plus the answer we got before, plus negative 60. So we have our integers here. Essentially, we're going to end up with negative 51. So we're going to end up with x to the power of 1 over x to the power of negative 51. Great. The other rule we haven't talked about is division. I'll do it on the side here. I know I should really make a box or something so that it's simpler to see. Let's do it black. Okay, here's our rules box. So our notes are a little better. The other one is if we have x to the power of a over x to the power of b, you can actually simplify this by writing xa minus b. Great. So that's the exact situation we have. So we're going to have just one base. Just have the one base here. And we'll have 1 subtract. And remember, this is negative 51. So if you remember your rules, we have like a negative of a negative. That simplifies into, this is the same as writing 1 plus 51. So we end up with x to the power of 52. So this question is asked, what will the value of the exponent be? Well, the value of the exponent is 52 in this case. That's our final answer for this question.